Hi, welcome to Turkish Engineering. In this lecture, we are going to study one-dimensional motion kinematics. So let's start by explaining each of these words. We will start with one dimension. Okay, what are dimensions? In the space, we have three dimensions. Okay, we have three dimensions. Let's sketch our coordinates to understand them more. So we have y-axis, we have x-axis, and we have z-axis. We cannot have more than three dimensions in this space. In physics, we have only three dimensions, and the motion cannot happen in more than three dimensions. But it can happen in three dimensions, two dimensions, or one dimensions. So we will start by only one-dimensional kinematics. Okay, so for example, if I'm moving only in the x-axis, I'm changing my position in x-axis, but my position for y-axis will be the same. So as you see, I don't have any displacement in y. My position will be stable in y and in z also. So in this case, my motion will be only in one dimension. Or in another case, if I'm moving only in the y-axis, I'm moving just forward in y-axis or just downward in y-axis in the negative dimension, in negative direction. So that will be only one-dimensional motion. In this third case, if I'm stable in x and y, but I'm just moving in z, okay, up or down, so it will be one-dimensional motion. So this is why we are talking about one-dimensional motion. Actually, in physics, you will take them step by step. You will understand basic principles of one-dimensional motion. Then you will be able to move to the two-dimensional motion, projectile motion, or sometimes types of two-dimensional motion as circular motion. After you understand all types of two-dimensional motion, you will be able to study three-dimensional motion. Actually, that will be in the college and in college level. But in high school, we only study one dimension and two-dimensional motion. Okay, so let's talk about motion. Of course, you know what's motion, but why physics is related by motion and why we are studying actually motion? So it's coming from our nature. You are moving, right? So you need to move. Even you are at rest and you are not moving, your blood in your body will move and your impulses will move. And when you look to your body, you will see your muscles. So actually, you are able to move and your muscles will make you able to move. And in your life, there is no chance to live without motion, right? For humans, it's very difficult to live without motion. So if we study and understand principles of motion, we can improve our life. So because we studied motion in past centuries, we are able to move now outside of the Earth. We can go outside of our atmosphere, so we can travel between planets, right? We can go to the moon, right? Not all planets, but we were able to move until the moon. So we traveled to the moon. So we went outside of the Earth. And all of these knowledges actually came from physics, studying physics. Basic principles of physics made us able to move, and our motion has improved to different and difficult levels, right? So this is why we are studying motion. Even in the Earth, in surface of the Earth, we will need to improve our motion. So we will develop new cars, new trucks to make transportation efficient, right? So motion is very important, and this is why we are studying motion. And what about kinematics? So This is just a term in physics. So motion can be studied in two parts. Okay, we have two parts of just motion. It can be kinetics or kinematics. Okay, we have kinetics and kinematics. Kinematics is studying the motion without considering the causes. Okay, in kinematics we are only interested about motion, and we are not interested in causes of the motion. But in kinetics we will study forces, okay, and energy and momentum, right? But in this part, just erase them. So we will not study forces, energy, and momentum, etc. But kinematics will have three parts. Okay, we have just three basic main parts. So we have displacement. Okay, displacement. We have velocity, and we have acceleration. Okay, if you understand these three main parts of kinematics, so you will be able to understand one-dimensional motion, two-dimensional motion, and three-dimensional motion. So what's displacement? It is change in position. Okay, it's change in position. If your position is changing, okay, and it will be represented by delta D. If your position is changing, so you are moving, so you can talk about displacement. And what about velocity? It is the second step. So we have three steps. We have displacement in the first step, we have velocity in the second step, and we have acceleration in the third step. So what is velocity? Velocity will be just change of our change of position. So it will be displacement, okay? It will be our displacement, but per unit time. So it is displacement, but actually it is just giving us what is we know we are making displacement, we are changing our position, but at which rate? Actually, how fast we are going, and we are changing our position. So it is our velocity, displacement per unit time. Okay, displacement per unit time will give us how fast we are going and how fast we are changing our position. So, and it will be represented by v. What about acceleration? Acceleration is our last part, okay, and it will be just change in velocity. As we said that we have velocity, which is displacement per unit time. We have acceleration, which is change in velocity, okay, change in velocity per unit time. So I will put here change in velocity, okay, or you can say velocity difference. Let's say change in velocity per unit time, okay, per unit time, and it will be represented by letter A, okay. So we have three basic things in studying motion. So let's start. Let's put some relations between of them. Okay, so displacement can be calculated by velocity. Velocity can be calculated by acceleration, but acceleration cannot be calculated from these things. Actually, acceleration will come from the causes. Okay, if you are asking why is acceleration equal to this magnitude, actually the reason is coming in kinetics. So in this part, don't ask why our acceleration is 2 meters per second square, for example. Don't ask this question, because the answer of this question will be given in kinetics part. In this part, we are not interested in causes of acceleration, why acceleration equals to this. But we can calculate it by knowing change in velocity per unit time. If you know what is your change in velocity per unit time, you can calculate A. So let us put some formulas, okay? acceleration is equal to our change in velocity per unit time. So it will be delta v divided by delta t. So it is our basic part. So we will move from acceleration to our velocity. So if you are asking for velocity function, okay, velocity as a function of time will be equal to our initial velocity plus acceleration times time. Okay, I'm just putting some basic equations which we will use them in our problems. Okay, so we have displacement. How can I calculate displacement? By using velocities and acceleration. So I will have initial velocity times time plus 1/2 acceleration times time squared. So why I multiply v initial by time? Why it's 1/2? Why it's acceleration, but here it's not time and time squared? These are coming from calculus, okay? So the reason of these formulas and why we are using them, you will understand these questions more when you study calculus. But in this level, we will just use basic algebra, okay? So ninth grade of high school level for math will be just enough for solving these questions, but because it is just introduction and beginner level for physics, okay? So there will not be complicated problems. It will be just based on basic algebra. So this is our delta D and displacement formula. As you see from the beginning, acceleration is related by velocity change in time. Okay, if you don't have any velocity change, so this part will be 0, so your acceleration is 0. If you have constant velocity, that means you don't have any velocity change, so acceleration will be equal to 0. What about this part? Velocity as a function of time. Actually, it is related by rate of your acceleration. So more acceleration, you will get more final velocity, okay? So you will have more acceleration. If you have more acceleration, you will get more velocity. And you must use your initial velocity because the addition will come after your initial velocity. Initial velocity always be there. Then you will just going up if you have positive acceleration. And you are going down, so your velocity is decreasing if you have negative acceleration. So acceleration can be positive or negative because your change in velocity can be decreasing or increasing. Also, displacement can be in positive direction and negative direction because your position can be going in positive or in negative. These are all vectors which just have magnitude, both magnitude and directions. So these are vectors. Acceleration has direction, so it has sign, minus or positive, minus or plus. So velocity also has minus or plus because they have directions, as same as they have magnitudes. Okay, so these are basic formulas which we will use them in our problems. Okay, if you understood what's displacement, what's velocity, and what's acceleration, it's enough for this level. We will solve some examples and I hope you will understand more. So see you in the next lecture. And in the next lecture we will just continue, but we will solve just problems. Okay, so explanation will be just over in this video. So we have some different problems. Okay, we will solve some different problems related with motion and non-uniform motion. Then we will study free fall. Okay, free fall, which is type of motion. Okay, and it's happening actually in y direction. If our motion is in x direction, just assume your car is going to east, so it is in x direction. If you are talking about vertical displacement, so it will be just falling down or going up, so it is free fall, and the gravitational acceleration must be considered in free fall because in our Earth we have certain amount of acceleration, which is gravitational acceleration. We will study them step by step, okay? So see you in the next lecture.